Hello students, this is how to find the line of best fit or linear regression. Okay, you have to have a graphing utility like Desmos in order to do this. You can also do it on a TI-84 or something, or a bunch of different calculators, but I'm going to show you on Desmos because that's what we have available to us most easily. So if you take a look at this scatter plot. I cannot draw one single line and have all of the dots fall on that single line. So what I'm trying to do is create a line that is equidistant from basically all the points. Now, if all of us tried to do this, we'd probably all come up with slightly different lines with slightly different slope. So this is our goal, is to figure out mathematically what is the exact line that would fall in the middle of that data. Okay, and this is a slide on how to figure that out. So what you're going to do on Desmos is, these are step-by-step instructions, but I'm going to actually show it to you. You'll see on this slide that's available to you in the resources what to do step-by-step. You're hitting the plus button, you're filling in a data table, you're typing in this equation. Okay, so let's actually do it so that you know what I'm talking about. So I'm going to come over here and I'm going to hit the plus sign, and I'm going to choose table. And then I'm going to type in the data. See this little data right here that they're giving you? Let's assume latitude is our X value. So we come in here and you've got to type it in. And here's where you can easily make a mistake. So you're going to double check your data after you type it in. And 60 and 70 and 80. Okay, so I typed in all the X values. Now I'm going to type in all the Y values that apply to that data. So you can see this is like kind of the time-consuming part. And again, if you make one small error, like a decimal point or something of that nature, then you will not get the right answer. So you got to double check your data. Seven and 1.0. Okay. Now I have all of my data into the table, and I'm going to do the next step, which is to have another line, and then you're going to type this into that line. So Y1, right? Y1, and now you're going to use this, it's called a tilde. See that little kind of curvy mark? It's called a tilde, and so then I typed in MX1 and then plus B. Okay, so I typed in, now this is something you're going to have to memorize. You're going to have to know this Y1 and then the tilde. That means approximate, by the way, that little symbol. Okay, and then it gives you some information, and this is what you're looking for. See, M, what's that stand for? Slope, of course. What's the B stand for? That stands for y-intercept. So find the line of best fit. Now here's how I would write my answer. Because remember, we're talking about y is equal to mx plus b, right? That's how you write the equation of a line. So I'm going to write y is equal to. Now I could use everything that they give me. Look in the instructions for the assignment you're doing to see, do they say to the tenths place? Do they say to, and the tenths, so this would be the tenths place. This would be the hundredths place. And this would be the thousandths place. So you have to look in the instructions to see what they tell you to round to. We're going to say round to the thousandths place. So that's negative 1.06. And if I'm rounding to the third spot, I see 0.605. So I'm going to round up and make that into a 1 instead of a 0. Okay. And then x, right, because that's a part of this equation, and then the B, the y-intercept. And again, I'm going to round to the thousandths place. So 3089 rounds to 309. Okay, now I've got my equation. Basically, you just got to make sure you're a good typist and then know how to identify the information here. Now this is a line, and it has an input and it has an output. These are inputs and these are outputs. Okay, and latitude is an X value, right? And the temperature is our Y values. Now, what are they asking in the second question? Estimate the average temperature for a city with a latitude of 25. So what is that? That's an input. That's an X value. So I'm going to take that 25 and substitute it in here for the X. Okay, and then, I mean, you can certainly do that math on the calculator. I have my handheld calculator, so I'm just going to type it in because I think that'll be a little bit faster. And then times, okay, so times 25. I did negative 1.061 times 25, hit enter, and then I'm going to add 92.309 to that. And I get a grand total of 65.784. Now let's look, what were they talking about? Estimate the average temperature. So they seem to be rounding their temperatures to the tenths place. So I would have, for my answer, I would say 65.8. And I guess we want to say degrees, right? Fahrenheit. Okay, so that is how you do that type. Now, let's look at another type of question that you would have to do this for. Okay. Okay, what if they give you dates, right? What if they give you, see how these are years? So you're not going to use these as the actual year. You're not going to type in 1980 as your X value. I come over here to my Desmos. I get rid of these old things. I guess you could have left that other one, but I go up to the plus sign. I get myself a table and I start typing in. So 1980 is going to be year 0. So then what is 1984? Well, that's 4 years past 1980. Then what is 1988? Well, that's 4 more years, so a total of 8 years past 1980. Then 92 is going to be 12 years past 1980. 94 is going to be 12, 13, 14 years after 1980. And then 1998 is going to be 18 years. Okay, notice that it didn't just go straight 4, 8, 12, should have been 16, right? And then 20 if we were just going by 4, but we're not just going by 4. We're looking at the data right here. And then we're figuring out if 1980 is year 0, how many years have passed since 1980 to get to 1984? That's where I'm getting the 4. Really, mathematically, what you're doing is you're saying, so if I wanted to figure out what this number should be, 1988 minus 1980, which was my 0 year, and that gives me 8, and that's why I'm using 8 for that data point. Okay, so that's the big difference here when you're talking about years. Your first year is your 0 year, and then from there, it increases or decreases depending on what the data is actually doing. Okay, so now we got to put in our Y values. Again, it's really important that you type it in correctly. That's basically a big part of how people can go wrong. Now, this is not increasing or decreasing in a specific way because this is a scatter plot. This is not linear data. It just doesn't go up to over one, up to over one, up to over one. Okay, it's not linear. It's dots on a graph. 382. Okay, so now I have my data in a table. Now I'm going to come down here, and this is the thing that you have to memorize: Y1, and then the tilde, which means estimate. Okay, and then you've got M X1 plus B. Okay, and that is going to give you the values you need for your line of regression. So the values I'm going to use are this M and this B value. And last time we rounded to a thousandths place. Why don't we round to the hundredths place this time, since it doesn't give us specific instructions. Okay, so the hundredths place is, oh, that wasn't a very good arrow. It's that second one. 2 places after the decimal. Y is equal to negative 2.2. Oh, so this was going to be negative 2.292. If I'm rounding to this place, I'm going to just leave that as a 9. Okay, X, and then plus 430.56. Okay, now that's our line of best fit. Then it asks you to apply this information to make an estimate. Estimate the 500-meter time for the 2012 Olympics. Okay, well, years, those are X values. Those are inputs. I'm looking for an output for the input of 2012. So what we have to do is subtract 2012 from 1980. So you can do this if you wanted to. I'm just thinking 1990, that's 10 years, 2000, that's 20 years, and then 32. So 32 is our X value. So what we're doing is we're going to substitute in here. So I have Y is equal to negative 2.29 times 32. Okay, remember the 32, where did I get that from? Let's just remember. Okay, 0 year was 1980. So to figure out for 2012, I had to subtract 1980 from 2012. How many years will that have been past 1980, my 0 year? 32. Okay, plus 430.56. Then in your calculator, I have my handheld, but you could certainly do it on Desmos. Then we are going to type in negative 2.29 times 32, hit enter, and then I'm going to add 430.56 to that. And I am getting a value of, so my answer, 357.28. Now, look at the time values that they're giving you. Number one, you could ask yourself, does that even make sense? Well, I think it kind of does. I mean, we're talking about 32 years from here. It looks like people are basically getting faster, right? That's what it looks like is happening. Usain Bolt or whatever. Super fast dude. So they have put this time in seconds, and so we need to round to a whole second. Okay, so 357 period. So 357 seconds. Now you're probably saying, well, why did you leave all these decimal point stuff if you're just going to round it at the end? Because it's more accurate if you leave these decimal places. The farther you go out with your decimal, the more accurate your data will be. Okay, and so we only round to the last second when we get down here at the very end of the problem. Okay, that is how you do those types. So you do really need to memorize this right here, Y1 tilde, MX1 plus B. That's super duper important.